Hello all. Today we are going to talk about uniform circular motion and dynamics of uniform circular motion. Okay, so if you all remember, we did kinematics part. I request you guys to go through the kinematics of uniform circular motion to understand this topic properly. Okay, otherwise I will just give a quick recap of it, right? So before going to dynamics, uh, let us just talk about kinematics. If you remember what is kinematics of so in kinematics we talk about velocity, acceleration and position. So in this case, let us say in this diagram, uh, let us first define what is uniform circular motion. So in uniform circular motion, you can see the speed is constant. Okay, so this speed is constant. So as it goes, speed remain constant. Fine. So now the main concept is that as the particle moves, let us say it was here at some time, it was here at some other time, and so on, its velocity is tangent. So if the particle is here, velocity is tangent to this point, and if the particle is here, the velocity is tangent to this point, and so on. Now even we have written v1 v2, and this let me just write v1 and v2 magnitude is going to be same because uniform circular motion. Now let us first ask this question, why velocity is tangent. Okay, so what happens uh, as the particle goes in circle, as you can see, so the particle is here, then the particle goes here, so you can see this one position vector will be this, and later on the position vector is this. Fine. So you can see that the position vector is, let us say, the first one is in this direction, r vector. Then after some time it is in this direction, that is also r vector. Fine. But you have to understand that this r will not get so change in position vector, if anyone asks, then it will be in this direction, change in position vector. So as the particle goes from here to here, you can take a nearby point also, idea will not change. The change in position vector is tangent, right? This direction is tangent. So we know that velocity is uh, change in position vector or displacement by time. So velocity direction will be in the change in position vector. So change in position vector is in happening in this direction. That's why the velocity is always tangent. Okay. So v vector is always tangent. Now coming back, let us talk about acceleration. Fine. So let us say the velocity is in this direction. We are writing v1 and this is v2. And then we are representing separate ways. So one parallel vector with v1 is this, and parallel vector with v2 is this. So again, this is the initial velocity, this is the final velocity. So change in velocity, let me put a vector, is in this direction. Fine. Which is towards the center. Fine. If I do it, then it is towards the center. So what happens, we all know that acceleration is change in velocity by time. So it turns out that acceleration is always pointing towards the center. Fine. So these are two very key points, that velocity is tangent to the point and acceleration is directed towards the center. And using simple vector rules, you can identify, and just try to imagine these 2 points are very close. So you will find that this is pointing in this direction. So velocity, this acceleration vector is in this direction. Now, moving on. If you guys remember, then we have some very important formulas. When I taught you, or there is a lecture on kinematics of uniform circular motion, you must go through it. I will just write the standard formalism here. So we define here one very important quantity called angular velocity. Angular velocity is defined as change in angle by time, just like linear velocity is uh, dx by dt. This is change in, so omega, roughly we write change in angle by change in time. Okay, now then this tangential velocity is related with this omega by this formalism, v equal to r omega. This is one important equation. And also, if it goes once, if the particle goes around once, if the particle starts from here and it goes one complete revolution, that is called time period. So there is also a formula which is omega equal to 2 pi by t. Okay, this is valid for one time period. Now, this only says that it goes once, and it describes 2 pi. 2 pi is 360 degree. Now, omega is measured in radian per second. Okay, radian per second. Now, you should also recall that from lecture of kinematics of uniform circular motion, that acceleration is equal to v square by r, where r is the radius. And if you guys substitute v value here, then you are going to get omega square r. So before moving, let us just recapitulate this point, that as the particle moves, goes in a circle, right? What happens if the particle is here, let us say, then its velocity vector is tangent to that point. Acceleration is towards the center, always, right? The same thing applies for here also. And the direction of omega is determined by right hand thumb rule. Okay, omega direction is determined by right hand thumb rule. So if the body is going in this direction, then you curl your hand along that direction, right? Thumb will indicate the direction of angular velocity. So in this case, the angular velocity is coming out, and we can go with our direction. This is x, this is y, and coming out we can say is z. So z is the direction of angular velocity here, right? And before moving, I will give you one exercise. Find out that whether v equal to r cross omega is true, or v equal to omega cross r is true. Actually, one of them is correct. So what you have to select, that whether this is correct or whether this is correct. Okay, remind me in the class, I will try to answer it. Fine. So now, going back to direction of omega, if the particle goes in this direction, if it revolves in this direction, again you rotate your hand, then the thumb will go inside. So that will be the direction of minus z, right? So in this direction, in this case, it is along z, and in this direction, if it goes in this direction, it will go along minus z. Now, Again, I'm saying go and have a quick look in this kinematics of uniform circular motion. Now, since we discussed that in kinematics, we talk about position, velocity, acceleration. When we talk about dynamics, when we talk about dynamics, we find the cause of the motion. Fine. Then the Newton's law comes into the picture. Now, moving on, let us take some important points. Okay, so first point, if you read in this slide, then it says that in a uniform circular motion, a resultant non-zero force acts on the particle. This is because the particle moves in a circle and is accelerated. Okay, just let me take down this, is accelerated even the speed is constant. So what happens as the particle goes in a circle, fine, then just now we said that suppose the particle is here, velocity is in this direction and acceleration is in this direction. Now what this point says that this acceleration occurs because there is always change in velocity, right? Now, so if I take a point here and here, let us say I take this point, so there is a change in velocity, and because of that acceleration comes into the play. Now this acceleration is pointing toward the center, right? So if the particle is here, the acceleration will be along this direction. If the particle is here, its acceleration will be in this direction. If the particle is here, its acceleration will be in this direction, and so on. For this region, this acceleration is known as centripetal acceleration. Okay, and this acceleration, if you right now remember, is given by v square r, or you can also write a equal to omega square r using v equal to r omega. So this is centripetal acceleration. It is always directed towards center. Fine. Now it also says that in uniform circular motion, tangential acceleration is zero. Tangent means in this direction. Since the particle is not picking up speed in this direction, tangent directions, right? Its speed is constant, as we know. So we conclude that along the tangent there is no acceleration. Fine. So in uniform circular motion, tangential acceleration is zero. Now we all know from Newton's law, second law, that net force on a particle is given by let me just write F for the net force, but you should understand that the net force on a particle is given by mass time acceleration. So if this thing has mass m, right? So the we also know that the force direction and acceleration direction is same, right? So the magnitude of the force will be mv square by r, or m omega square by r. This is the magnitude of the force. So force, let us put a different color to it. So force will be also in this direction, right? And that force is along the direction of acceleration, and that force is given by this mass time acceleration. This is called centripetal acceleration. We can also write it like this. Now this force is called centripetal force. So therefore a centripetal force of magnitude of the force we have just written, mv square by r, is needed to keep the particle in a circle at constant speed, let us say v. So whenever anything goes in uniform circular motion like this, okay, we'll take some example. Then you need a non-zero force in this direction so that it can means it can go in a circle. Fine. Now, this again, this is also called centripetal force. Centripetal force or centripetal acceleration. Centripetal means center seeking. Okay, so this word means center seeking. Okay, now moving on. Uh, Now, next point we are going to discuss is the most important, that centripetal force is not a new kind of force. Okay, centripetal force is not a new kind of force. This force must originate from some external source like friction, tension, electrostatic, gravitation, etc. We'll have a look at it. So let us see that suppose there is a fly sitting in a disk. Okay, and it is going in this direction, as you can see. Now you can all guess, let us say this fly has mass m, right? We know that the acceleration will be in this direction, so force is also in this direction. Now this force is called centripetal force, right? The same goes for here also. Now this force, in this case, can you guess what force will be that? Friction, tension, electrostatic force, gravitation. So it turns out, if there is no friction, okay, just try to imagine, then the fly cannot go around a circle, right? Now, so in this case, what is happening? Try to understand that this fly is going with the record, okay, round and round. So since it's going in round and round, it needs a force in this direction, and it turns out that must be friction. So this force which makes the fly go round and round, this centripetal force in this example will be friction. So here friction will be the centripetal force. Okay, fine. Now same way I can take one example more. Let us say we have a sun here and this is earth. We know that earth goes in a circle or ellipse, whatever. So its velocity is tangent. If it goes in a circle, it needs a force, right, which will be directed towards center. We know that sun attracts the earth, so there is a force, and this force is gravitational force in this case. Okay, sun is putting a gravitational force on earth. So that gravitational force will act like a centripetal force in case of sun. And uh, so gravitational force will act like a centripetal force. We can go on, we can say that this is nucleus, which is positive charge, right? This is electron, which is negatively charged, and we know that electron goes round around the nucleus. So what kind of force exists between the positive charge nucleus and electron? So it turns out that is a electrostatic force, right? Na? So what happens, because uh, this nucleus is positive charge, electron is negative charge, the electron feels a force in this direction, and due to that it goes in a circle. So in the case of atom and its orbits, friction centripetal force will be provided by electrostatic force in case of atom, right? So in this case friction is providing the centripetal force, in this case gravitation is providing the centripetal force, in this case electrostatic force is providing the centripetal force. Now moving on, uh, you can see, let us talk about this. So this is being this is a string, this is a mass, let us say m, and it is going in a circle. Now can you guess which force will provide the centripetal force here? So if you guys, if you can guess, you know that as you start moving, there will be tension acting on this, right, in this direction. And due to this tension, it will describe a circle. So tension will provide the centripetal force here. When you are making a stone attached with a string goes in a circle. Now, so in this case, tension is providing the centripetal force. Now, last example. You can see here that there is a car. It's going to take a turn. We can imagine this to be a circle, part of a circle. So if it is going in a circle, we know that its acceleration will be toward the center, right? So there must be a force in this direction, which we are calling centripetal force. Now, can you guess which force will provide the centripetal force for it to go in a circle? Now, if there is no centripetal force, okay, then it cannot go in a circle. Fine. So it turns out again that this centripetal force will be nothing but friction. So if there is no friction, let us say, so what will happen? You will follow this straight line and you will, okay, if there is no friction or there is no force, you cannot bend your path. Fine. You will follow this straight line because of Newton's law of inertia. If there is no force, there will be no acceleration in this direction. Now, this part is very important, that we need friction during turn. Fine. And this application we are going to discuss in next class. Now, your takeaway should be this, that in uniform circular motion, you need a force towards center, and that force is called centripetal force, and that force is not a new kind of force. It must originate from tension, electrostatic force, or whatever name you guys know. Fine. Thank you. I will see you in my next class.